Again, Chapter 4, triangles. We classify triangles according to their angles and according to their sides. There are 4 different types of triangles based on angles. A triangle that has 3 acute angles we refer to as an acute triangle. A triangle that has 3 equal angles. Notice the prefix equa, meaning equal. Angular, meaning angles. Okay. Anytime you have 3 equal angles, that is an equiangular triangle. A triangle with a single obtuse angle. And a reminder, an obtuse angle is an angle that's bigger than 90 but less than 180 degrees. Anytime you have a single obtuse angle, that is an obtuse triangle. And a lot of you might be asking the question, hopefully you're not, that, well, to be an acute triangle, it needed all 3 angles to be acute. Well, why does an obtuse triangle not need 3 obtuse angles? Well, guys, if you have one obtuse angle and you try to throw in another obtuse angle, I don't think you're going to have a triangle. Correct? So an obtuse triangle has one obtuse angle. A right triangle, the same thing. A right triangle has a single right angle. And I believe it would be impossible to have 2 right angles. It wouldn't be a triangle again. So therefore, a right triangle has 1 right angle. Make sure that you know those: acute, equiangular, obtuse, right. And again, take notes. If you already know that, you don't write it down. Right? If you already know what those 4 types of triangles are, don't even put it in your notes. You're already good. Classify each triangle as either acute, equiangular, obtuse, or right. Megan, what kind of triangle would this be? Good job. That's an acute triangle because it has 3 acute angles. What kind of triangle would this be, Erica? A right triangle because it has 1 right angle. And finally, Jordan P., what kind of triangle would this be? Because it has the single obtuse angle. And that would be equiangular. Okay, according to its sides. If a triangle has 3 equal sides, we call it an equilateral triangle. Now let's discuss something. If a triangle is equilateral, you know what else is true about it? It's also equiangular. All 3 sides are going to be the same, and not only are all 3 sides going to be the same, but also all 3 angles. An equilateral triangle and an equiangular triangle, guys, pretty much same thing. But if we're describing its sides, equilateral describes all 3 sides being the same. Equiangular describes all 3 angles being the same. But in essence, it's the same thing. An isosceles triangle has 2 equal sides, the same, and I call it an isosceles. Some of you pronounce that isosceles, a short I. Here's the way I remember it. Isosceles, you got 2 I's, right? Isosceles, the same way you have 2 eyes, you have 2 equal sides in an isosceles triangle. Scalene has no congruent sides. So all 3 sides are the same, it's equilateral. 2 sides are the same, it's isosceles. No sides are the same, it's scalene. Classify the let's see, pretty much classify this as either equilateral, scalene, or isosceles. JC. Side lengths of 16, 16, and 18.5. What kind of triangle is that? Good job. Isosceles. This one, a little bit tougher. It says if point M is the midpoint. That's the midpoint. Well, they're throwing in all those old definitions. We have a length of 1.5, and M is the midpoint. Claudia, tell me how far it is from J to M. If this is the midpoint, the whole thing is 1.5. You need to type it in your calculator. What's the distance from J to M then? So the whole thing's 1.5. She divided by 2 and found out that this was 0.75 and this is 0.75. And notice also we have tick marks, which makes this 0.75 as well, right? And it says classify, look what triangle you're talking about, triangle JKM. Triangle JKM, this triangle. It says classified as either equilateral, isosceles, or scalene. What do you think, Destiny? What kind of triangle is it? It's equilateral. Good job. all three sides. And before, it probably didn't look like equilateral, right? Before we did the computations and found out that everything's 0.75, we wouldn't have realized that. So that is an equilateral. Anybody, what's the other one going to be? It's isosceles. And we knew that before, right? Because they gave us tick marks. That is isosceles. Next problem. Find the measure of the sides. And again, you're going to be pretty good at algebra by the time we get to the end of geometry. Find the measures of the sides of the isosceles triangle. So they give us isosceles. They give us the tick marks. Be careful about how you set this thing up. Because so many people is going to sit there and say, oh, we did these back in chapter 1. You do 4x plus 1 plus 5x minus 0.5 plus 9x minus 1 equals, and you don't know what to put there. Right? This is not like the problems you did back in chapter 1. The problems in chapter 1, they told you what the perimeter was. They don't tell you anything about perimeter here. Now, if they gave you perimeter, yes, all three of the sides add up to the perimeter, but that's not what they say. Let's erase this. Since we know it is isosceles, though, we do have a relationship between 4x plus 1 and what other side, Stephen? And we do know that those two sides are what? Because they are isosceles. That makes sense. So we know that 4x plus 1 would have to equal 5x minus 0.5. We solve it by subtracting 4x. We now have 1x. And adding 0.5, we get that x is 1.5. That's not the answer. It says find the measures of the sides, not find x. So once you find that x value, you have to plug it back in. Since x is 1.5, we plug it in for all of our x's. 4 times 1.5 is 6. 6 plus 1 is 7. So this side is equal to 7. 7.5 minus 0.5 is also 7. So we got those two sides. And we get 9 times 1.5 is 13.5 minus 1, which I believe would be 12.5. You have a triangle with side length 7, 7, 12.5, and we know that that is isosceles. Where we're headed with this, and I could actually, the end of the, I believe it's next chapter, I could give you this exact, no, it's 2 chapters from now, I could give you this exact same problem, and I could actually ask you something different. I could say, how big is this angle right here? Or how big is this angle right here? We're headed into the realm of there's a relationship between, when you've got a triangle, there's a relationship between the side lengths of that triangle and how big the angles are. And that relationship is deals with a branch of mathematics called trigonometry, where you're dealing with sine, cosines, tangents. You might have heard of those before, but that's where we're headed with this math here. Same thing, find the measures of the sides of the equilateral triangle. Remind me, Rachel, what do we mean by equilateral? All three are congruent. So we've got a dilemma here, right? How do you set this problem up? Somebody help me out. 3y minus 3 equals what? Any idea? Does it equal 2y plus 5? Does it equal 5y minus 19? Does 2y plus 5 also equal 5y minus 19? So which way do I set it up? Any way you want to. If we did it correctly, we should get the same answer any of the 3 ways. Let's test it. Move our 2 y's over here, gives me 1y. Move minus 3 over here, gives me plus 3, so y is 8. Move 3y over here, gives me 2y. Move 19 over here, gets 16. Divide by 2, you get y equals 8. Move 2y over here by, what's that supposed to be? 5. Move 2y over here, you get 3y. Move 19 over here, you get 24, and y equals 8. So to make a long story short, y equals 8. Set it up any of the ways that you want to. Now, if you set it up 2 different ways and got 2 different answers, something's wrong. Y is 8. Now let's test it. If y is 8, 2 times 8 plus 5, anybody? Thank you. 3 times 8 minus 3, 21. 5 times 8 minus 19, 21. So that it checks out. It's equilateral. If it didn't check out like that, we did something wrong. And again, I'm getting ahead of myself, but there is a relationship between side lengths and angles. Can anybody tell me how big these angles are? How big are those three angles? You may know. They're actually each equal to 60 degrees. Like I said, I'm getting ahead of myself, but in a triangle, they all have to add up to 180. So it has to be 60, 60, and 60. If it's equilateral, it's also equiangular. And there we go. That led right into this. The triangle angle sum theorem, which you might already know. The triangle angle sum theorem. The sum of the measures of the angles of a triangle is always 180 degrees. That's extremely important. You're going to be using it again the rest of the year. So the three angles of a triangle always have to add up to 180. This should make more sense now. So why can an obtuse triangle only have one obtuse angle? How big is an obtuse angle? Bigger than what? 90. So take two angles bigger than 90. Add them up. You're already bigger than 180, aren't you? So it's impossible. Or take a right triangle. A right triangle has one right angle, not two. Because if you had two right angles, that'd be 90 and 90, which is already, again, bigger than 180. Question. Could a right triangle have a 90-degree angle and an 89.5-degree angle? And what would it look like? Would it look very similar to that scenario I drew a while ago? If this is 89.5 degrees, sure. Would those ever cross? If I kept drawing these lines, would they ever cross? Yeah. Are those two lines parallel? Oh man, now we're getting into the other stuff we talked about. Are those parallel lines? Those two angles right there are called same side interior angles. And since the same side interior angles are not the same, those two lines are not parallel. Now they're close. They're extremely close. They're going to look parallel. And if you keep drawing those lines for a long time, they're still not going to cross. But if you draw them, goodness, it would take forever, wouldn't it? Eventually, somewhere around the moon, those two lines would cross. Okay, it would take a long time, but those two lines would cross, and you would have an extremely, let's see, what's that called? I believe it's called a hypotenuse. You would have an extremely long hypotenuse. Okay, but they would eventually cross because those are not parallel lines. But again, I say all that to say this. The three angles always add up to 180. Here's a proof. And we're not going to do the proof. I'm going to talk about it. The proof involves parallel lines. Let's actually, instead of looking at the proof and make our head hurt, let's just show you what the proof says. Okay, here we go. What I'm going to do is I'm going to take and draw a third line, or excuse me, a fourth line that is actually parallel, and that's called an auxiliary line, and that's always legal. You can draw any line anywhere you want to, just for the heck of it. And I'm going to call that an auxiliary line. Now, my question for you is, look at these three angles, 1, 2, and 3. Somebody tell me something true that you already know from previous things. What's true about those three angles? What do they add up to? 180. Why? Straight line, right? So is 1, 2, and 3, do they form a linear pair? No, there's three of them. Okay, two of them's pair. But they do form a straight line, so linear triple, I guess, if you want to say it. Those three add up to 180. Now, question, though. I just drew this line that's parallel to this. What's true about this angle and this angle? Did I see the Z? They're the same. Those are alternate interior angles. So what I'm going to do is, instead of putting a question mark, I'm going to put a 3 there too, because I know those two angles are the same. What about this angle and this angle? Aren't those also the same? So didn't you say that angle 1, angle 2, and angle 3 added up to 180 here? Well, this is the same as angle 1. This is the same as angle 3, so would this angle 1, 2, and 3 not also add up to 180? That's the reason why. That's a proof of the three angles of a triangle will always add up to 180 degrees. First problem. Kyle, help me out with this one. Keep you awake. The diagram shows the path of a ball in a passing drill created by four friends. Find the measure of each numbered angle. Kyle, we're given that this, I'll blow it up so we can see it better. There we go. That looks better. We're given that this is a 20-degree angle. This is a 78-degree angle. Kyle, use your calculator there and find out what angle 3 is equal to. The three angles of a triangle will always add up to 180 degrees. And Kyle knows, as he's typing it in, that 20 and 78, that already gives him 98. And the 3 has to add up to 180. So he subtracts that off and finds out that angle 3 is what? 98 and 82 degrees. Everybody okay with that? Now again, we're running into old material. How big, Chris, is angle 2? And why? I'll tell you the why. Vertical angles. So how big would angle 2 be? Any ideas? No? What do you think, Connor? Help him out. 78 degrees. Vertical angles, and y'all remember vertical angles? Anytime you have two intersecting lines, this angle, they're vertical. This angle, they're vertical. Vertical angles are always congruent. So do you see the 78 at the top? The angle straight across from it, since you have intersecting lines, will also be 78. And help me with the third angle here, Abby. You got a 78-degree angle, a 61-degree angle, and now I need to know what angle 1 is equal to. I believe 78 and 61, as she's typing it in, gives me 139, which leaves me with how many degrees, Abby, for this one? 41 degrees. Same thing, find the measure of each numbered angle. And again, all these old theorems, all these old postulates are coming back to us. Well, in this triangle down here, I've got that this is 57 degrees and this is 71 degrees. So Brianna, 57 and 71, I add those together, I get 128. I need to know how much more is left of the 180. What do you get for angle 2 there, Brianna? 52 degrees. Now, what else could I do on your test? Well, I could give you a problem like this, and I could say, not find the missing angles, but tell me what kind of triangles do you have. Are they equilateral? Are they equiangular? Are they isosceles? Remember that? So this would be actually... none of them are the same, right? They're all acute, though. So that's an acute triangle. This triangle down here would be an acute triangle. Y'all know something else, too? If the angles are not the same, I'm going to go ahead and share a secret with you. If the angles are not the same, the sides are not the same. Okay? If two of the sides are the same, then two of the angles will be the same. If all three angles are the same, then all three sides will be the same. There is a relationship between sides and angles. Now I'm going to make this difficult, Tony. I want angle 3 next. And so many people, when they're working these problems, they see the little pictures, but they fail to see the big picture. And that's the reason I want angle 3 next. Because so many people see two triangles here, right? Guys, how many triangles are here? There are 3 triangles. Does everybody see 3 triangles? Okay, there we go. Now, for those of you that see 3 triangles, can you find angle 3 now? My advice for you is when working these problems, don't fail to see the big picture as well. You have a small triangle, which we just worked. And so many people just see this other triangle here, and they don't see the big triangle. That's the whole picture. This is 52 degrees. Well, how in the world do we know what that angle is? That's called the triangle angle sum theorem. If you have a 28-degree angle and a 71-degree angle, I believe that whole angle would be 99 degrees. Which, by the way, guys, makes this big triangle obtuse. So if you have 99 and 52, that gives you 151, which leaves you with 29 degrees. But, of course, that's probably not the way you would have worked it. The way you would have worked it was went ahead and found angle 1. I believe this forms a linear pair is what we called it. Anytime you have a linear pair, we know that these two angles have to add up to 180 degrees, so this would be 123 degrees. There's all your missing angles. Any questions? Next problem, they give you that angle 1 is the same as angle 2. See the tick marks. Tells you about congruence. But before I did angle 1, well, yeah, let's do angle 3 first. Kirsty, one more time, what does the 3 angles have to add up to? Perfect. So therefore, Vanessa, we've got in this triangle down low, we got a 23 and a 24 degree angle. That adds up to 47 degrees, Vanessa. So therefore, if that's 47, tell me what's left for angle 3. 100. $47. These two add up to 47, so you're left with 133 degrees. Everybody good with that? Now, angle 1 and angle 2. Jackie, we only have one angle here. It's equal to 105 degrees. And we're missing 2 in that triangle. But those two are the same. Jackie, what will these two angles add up to? How much is left? 105, take that away. How much are we left with for these two angles? Perfect. They both have to add up to 75. We know they're the same. So take your 75 degrees and split it in half. And you get 37.5 degrees for this one and 37.5 degrees for this one. Again, making that triangle, well, we don't know anything about the side lengths. Yes, we do. Two angles are the same. Two sides will be the same. That's going to be an isosceles triangle. I'll tell you what, they don't ask us for it. Let's go a step further. Anybody tell me how big this angle is? Angle WXY. A lot of people didn't even see that angle, did they? That goes into some old stuff as well. If you're given that this is 105, this is 133, well, that's a good size angle, isn't it? That's bigger than 180 degrees. How can an angle be bigger than 180 degrees? Guys, you can have 360 degree angles, you can have 700 degree angles. It all depends on how you're rotating them. Just extra information, if you add 105 plus your 133, you get 238 degrees. This is a 238 degree angle. That's bigger than 180. So how do you find the rest of this angle? You may know. Subtract it from what? 360. All the way around is a 360 degree angle. You would be left with a 122 degree angle would be this angle, just in case you ever have to do that. Last problem. Extended ratios. Again, go back to old stuff. Ratios. The three angles of a triangle adds up to 180. It says these three angles are also in ratio of 1 to 2 to 3. The same way that ratio of boys to girls might be 3 to 5. Okay? 3 and 5 is not how many boys and girls you have. That's the ratio of boys and girls. So what they're giving us here is that three angles in a triangle are in ratio of 1 to 2 to 3. That's not the size of the angles, that's the ratio of the angles. The actual size of the angles are some multiple of 1, 2, and 3. So the actual angles are 1x, 2x, and 3x. Again, what do they have to add up to? 180. So do you see how to work these problems? If the ratio of the angles are 1 to 2 to 3, we know that those three angles have to add up to 180. So there's your problem. Ratio 1 to 2 to 3. 1x, 2x, 3x has to add up to 180. I believe if you put those together, you get 6x is 180, so x must be 30. Which makes your three angles, which were 1x, 2x, and 3x, are now 1x, 2x's, or 230s, and 3x's, which is 90. And oh, the possibilities. I could have gave you that problem and said, you know what? What's the size of your middle angle? What kind of triangle is that? I could give you the length of one or two of the sides, because later on we talk about 30, 60, 90 right triangles. This is actually a special type of right triangle. There's relationships between legs and hypotenuse in a 30, 60, 90, but there's your actual triangle. It's here's a picture of it, by the way. 1x, 2x, and 3x are the three legs. If x is 30, You can take and check that 30 plus 60 plus 90. Does give you 180. If you reduce 30, 60, and 90, you get 1, 2, and 3. Here, though.